Okay, so let us start your snap interview for heat transfer. Okay, so first of all, just tell me, what are the various modes of heat transfer and how do you define them?
There are three modes of heat transfer: conduction, which is by the one molecular level, one to one, and second one is convection. It is because of the fluid flowing over the body, and because of the movement of fluid, that is the conduction plus advection, it leads to convection. And the third one is radiation, which is because of the high temperature of a body, and this process takes place in vacuum.
Okay. Okay, tell me some of the assumptions of the Fourier law.
Fourier law states that the assumption first one is the it consider for the 1D heat transfer in only one direction, and the thermal conductivity of the body will remains constant, and it should be in steady states.
Hmm. Okay. Okay, let us suppose if you have a body, okay, a three-dimensional body, and the heat is transferred in all the directions. In that case, how do you write the energy balance equation?
Energy balance.
Yeah, energy balance equation. So there is a simple three-dimensional body, and the heat is transferring through all the directions. In that case, the energy, write down the energy balance equation is shown.
E in minus E out is equal to change
Hmm.
in internal energy of the body, MC
Okay,
delta.
and also mention the let us suppose it is a case of a heat. There is a heat generation inside this body, and also just write down the temperature distribution.
For Cartesian,
Yes, for Cartesian coordinates.
d square t by ds square plus d square t by dy square plus d square t by
Hmm.
dz square plus qg by k is equal
Hmm.
to 1 bata alpha dot t by dot t.
Okay, and let us suppose if there is a slab, okay, and the heat is transferring through it through only in one direction, and there is no okay, here you can assume there is a simple slab, okay, and the heat is flowing through it in a one direction only. Okay, and correspondingly the temperature is constant. It is not changing with respect to time. Okay, in that case, what will be the shape of the temperature profile and what will be the value of the slope?
Temperature is not changing with time. Yeah,
Yeah,
directly.
yeah, the temperature is not changing with time. Okay, but there is a uniform heat generation inside the body. In that case, what will be the temperature profile and what will be the value of the slope of the temperature
Uh,
profile?
so the temperature profile will be a parabolic in nature,
Hmm.
and d square t by dx square is equal to qg by k. We have to find the differential if qg by k is equal to 0 as a steady state, and from the temperature profile it come out to be qgx square by 2k plus c1x plus c2, and and for correspondingly we find the maximum and minimum where it will be at a distance x where it will be maximum.
Okay, just apply the boundary conditions and tell me the final equation.
We find
Yeah. Generalization, just fine. Just put the boundary condition here and find out the
uh,
exact temperature distribution formula.
so what sir boundary one surface is insulated or daily temperature.
No, both of the sides are uh, open to the atmosphere.
What's up? What's up?
Both of the surfaces are open to the atmosphere. None of them is insulated.
It is visual.
Yeah, it is visible to me.
QGS square by 2K, QGL by 2K plus X plus T atmospheric, and I have derived from here. Uh, uh,
Hmm. Okay, okay, that is okay. Okay, let us suppose
uh,
if you have a cube. Okay, there is a simple cube, and all of its surfaces are maintained at a different temperature. Okay, let us say the bottom surface is maintained at a temperature of T1, the top surface is maintained at a temperature of T2, and all the lateral surfaces are maintained at a temperature of T3. In that case, what will be the radiation network diagram? Here you can assume all the surfaces are black surfaces.
black surface.
Yes. Then what will be the temperature radiation network diagram?
And that
Hmm.
so there will be only safe
Hmm.
safe resistance of the body because this is considered a black body. Then only the heat transferred by A1 F12.
What is this one fourth number point? There are only three surfaces. The bottom surface is maintained at a temperature of T1, the top surface is maintained at a temperature of T2, and the side surfaces are maintained at a temperature of T3. What is that fourth point?
Okay. Then, sir, in the lateral side, there will be no any heat transfer, only transfer
Why?
from uh, because they are at the same temperature.
Okay. And what changes you are going to see if the, let us say, the bottom surface is not a black surface, it is a gray surface.
Uh, then surface resistance will come into 1 by
Okay. What changes you are going to see in the radiation network?
just one more resistance will be there, 1 minus epsilon by epsilon A1. Uh, if only one surface, one is a gray body, not a black.
Okay. Let us say in that case you want to calculate the value of the net radiation heat exchange between 2 and 3. Okay. Then what will be the formula of the final formula of the radiation heat transfer?
Between 2 and 3, we have to solve
Yes.
by using the series or parallel combination.
Just solve it. We have already drawn the network diagram. No? Just solve the equation.
This one I'm
Okay. Okay. What is Stephen Boltzmann law?
A second, Boltzmann law for black body states that total radiation heat transfer is directly proportional to fourth power of absolute temperature.
Okay. And what about the Planck's law?
Planck's law that the energy emitted by a body is directly proportional to frequency of the E is equal to h mu.
Are you sure? That is the wrong statement. It doesn't tell you about the energy. It tells you about the monochromatic emission power.
I'm not.
Okay, just tell me one thing. In this Stephen Boltzmann law, you have said that the total emissive power is directly proportional to the fourth power of the absolute temperature. Okay. Now, according to the Planck's law, how does the monochromatic emissive power varies with the temperature? What is the power here?
Fifth,
Just prove me how it is coming out to be fixed.
सर प्लैंक्स लॉ C1 लैम्डा का पावर -5 और E का पावर C2. Sir, if we neglect some terms and we will put lambda maximum t replaced by this lambda maximum t is equal to constant, lambda is replaced by c by t, then we get t to the power 5.
Okay, that is okay. Okay, suppose there is a pipe. Okay, and the fluid is flowing through it at a very high temperature. The pipe surface temperature is very low as compared to the fluid temperature. Okay. Now, if you want to cool down the fluid temperature in a very short period of time, then what changes you are going to do? What modification you are going to do here in the pipe? You cannot change the diameter of the pipe.
So we should place in a medium like refrigeration. We should provide a refrigeration medium.
You don't have to use any external machines or any device. You just have to modify the pipe. What are you going to do?
Without changing the diameter.
Yes, without changing the diameter. Without changing the diameter as well as without changing the length of the pipe.
So, if possible, we can change the roughness of the pipes, then the heat transfer coefficient will be more in this case.
Okay. How will you change the roughness of the pipe? Will you
Uh,
increase the roughness or make it more smooth?
it will increase the roughness.
Okay. Then what will be the effect?
In this case, the flow will be turbulent and the edge corresponding the edge will be more, and also the developed region will be the length of the developing region for the turbulent flow will attend at a minimum time, and the mixing will be more
Okay.
in case.
Okay. Okay. What is the variation of the heat transfer coefficient along the length of the pipe if the flow is laminar as well as the turbulent?
First of all, the for developing region it will be decreased for laminar delta
Just show me the
x.
graph between the heat transfer coefficient along the length of the pipe for the laminar as well as turbulent flow. Okay. Yeah, it is for which case? Laminar or turbulent?
Laminar.
Laminar. Okay. And what about the turbulent? Just draw in the same diagram. Okay. Okay, that is okay. Okay, so now let me provide my feedback. See, the answer which you have given me regarding the heat transfer coefficient are almost correct. Okay, there's no need to worry. Okay, just do one thing, just revise the concepts of the radiation part. Okay, because in radiation you are a little bit weak. Okay, just go through I think you forgot the formula of the Planck's law. Yes,
Yes,
because you
sir.
know the procedure, but you are not, you don't know the value of the monochromatic emission power formula. You know? So just go through that particular formula and how can you drive the relationship that is E is directly proportional to the temperature to the 3 to the power 5. Okay, just go through the derivation. That's a very simple case. Okay, and remaining else in the convection part, just go through the basic experimental formula that how does the what will be the variation, and the answer which you have given me regarding the smooth pipe and rough pipe are correct. Okay, I was expecting this part only. Okay, just by making the roughness, but just by increasing the roughness of the pipe, you can increase the heat transfer coefficient in the corresponding heat transfer case. Okay, that is almost correct. Okay, just do work on your delivery part because it has to be improved. Okay, so just work on this thing. Anything else you want to ask?
सर वो टी का पावर 5 कैसे आएगा वो?
उसमें कुछ नहीं करना। अब आपके पास प्लैंक्स लॉ का रिलेशनशिप आपको पता है, एक बार बुक से प्लैंक्स लॉ का रिलेशन देखना। ठीक है,
Okay.
उस केस में जो सिर्फ वेरिंग पैरामीटर होंगे वो सिर्फ लैम्डा और टी होंगे। फिर आपने जो मुझे बोला जैसा वेन डिस्प्लेसमेंट का लॉ यूज करके, वो सही था बिल्कुल।
Okay.
लैम्डा को कन्वर्ट करो टेम्परेचर टू द पावर सी बाय टेम्परेचर, सिंप्लीफाई करो, यू विल गेट योर आंसर। ओके, जितने भी पैरामीटर्स है वो सबके सब सेपरेट हो जाएंगे, वो एक कांस्टेंट कि आप उसे रिप्लेस कर सकते हो, जो रिमेनिंग पैरामीटर बचेंगे वो टी टू द पावर 5 फॉर्म में ही बचेंगे। ठीक है ना? आपके पास डिनोमिनेटर में कुछ एक्सपोनेंशियल टर्म्स होगी, उनमें भी जब आप पुट करोगे वैल्यूज को वो कैंसिल आउट हो जाएगी पूरी। डोंट वरी। ओके
Thank you.
ओके ओके, सुनो, नाउ यू कैन लेट द मीटिंग।